Alright, this is another one. I don't remember if I did a earlier video on this or if it was part of the live stream, but I actually broke the warranty seal on this. It's never been apart before, so I'm the first one in here. And if you remember, we've got a blown power supply. No idea why it blew up until we figured out that this thing is all burnt and arced out. So you're not going to be able to find one of these. So what I'm going to have to do is I'm going to have to try to clean this up and actually redo it. Or, try to clear out the shorts, clear out the carbon. And the way I'm going to fix this is I'm going to try something. I'm going to try this right here. This is an insulating varnish. Electronics type thing. I want to see how this works. I guess we're going to find out. We're going to try that out and see how that works for cleaning this out. But in order to do that, I got to get this board out, and I got to get that out especially. So next thing you do is get it all apart. Yeah. After pulling the wire, or pulling the inductor off, I started looking at it, and the wire is shorted across to other wires. It's dangerously pitted. I have to replace it or rewind this whole thing. And then as I removed it, that one broke off. So I'm going to have to rewind it. And this is just it looks like a 40 turn bifilar wound choke, filter choke. Nothing crazy, but yeah, that sucks. That's exactly what I wanted to do, is to rewind this sucker. Oh well, is what it is. I'm going to have to get new wire. I got to figure out what size wire this is and order new wire. Nothing I can do about it except fix it. Alright, so as we discussed earlier, I cannot repair this coil easily. There's some damage here. There's some severe pitting, in the coil. Anyways, so this is a 1.2 millihenry or 1.9 millihenry inductor. I checked it with my LCR meter. And this is the old wire I was going to try to patch and unwind. I got to figure out there's 40 turns of that. And it looks like it's bifilar wound. It's paired up in parallel there. So here we are, a week later. Now we have this, courtesy of Amazon. So I took my calipers. This appears to be roughly, this is in metric, but appears to be roughly an 18 gauge wire. So I got the two different colors here because you have this clear lacquer and then you have this red lacquer. So here's the clear, and then in here should be the red lacquer. So this and this should allow me to rebuild that. Now, unfortunately, I do not have a toroid winding machine. So I'm going to have to do this by hand. I'm going to have to measure this out, make two wires exactly this length. Actually, I want to add like a foot or two onto it here just to compensate, because there's no way I'm going to be able to hand wind this without a machine this tight. It's going to have a little bit more of a bulge. It's not going to be perfect. There's going to be overlaps. So, and this is just a filter choke, so it's not that important anyways. It's important enough to where it filters the noise, but it's not going to be super critical. So I need to get this. I want to add a foot or two of length to it just to compensate for any error. And I'm going to feed it through extra like that instead of like where it was. So I'm going to start with like that, I think, somewhere around there. We'll see. And then do it. So I got to cut out two lengths of this wire because this I don't have a machine, because even if I had a machine, I'm having a hard time figuring out how it would work, because this is your spool that can't pass through here. So in order to pass the wire through here, this thing has to, because I don't know, I've seen on Google Images, there's this big wheel thing, and this thing sits in the center of a wheel, and the wheel just rotates and brings the wire in while this thing slowly turns. Well, the problem is, how does the wire, how does this you see my point. Anyways, so I'm going to go ahead and take care of this and get this thing fixed. I'm going to wind one winding first. I'm going to unwind this one and then wind it back just like this. And then I just took some time to study the amplifier, and the way this actually works is exactly how you see it here. The transformer, or the inductor, sits like this. So the circuit path comes this way on one winding and then comes this way on the other winding. So as long as I keep them even here, I want to try to center them and keep them even here, and then I'm going to keep the other ones even there. So that's how we're going to do this. Well, I got coil number 1 wound, and I was actually doing pretty good until I realized that the winding, as I was winding, it was going to come out over here, and I needed to come out over here. I don't know how they calculate that out at the factory, but I messed up, and obviously you can see where I got aggressive at the very end. You know, so it's going to make it fun to wind the red winding on top of this. Anyways, I did another inductance check. This was 1.2 millihenries. Now it's 1.9 millihenries. So I've increased it somehow. I might have an extra winding here by accident. I'm not sure, but oh well. It's a filter choke. It's not perfect, and these aren't made anymore anyway. So it's just gonna have to work. Well, that was a royal pain in the ass, but I managed to finally do it. And I tell you what, I'm not going to do another one of these again ever in my entire life, because that was just painful. Old wires over there, but whew, it's done. About 2 to 2.1 millihenry. It's supposed to be 1.9, 1.2. I don't know. It's close. It's not quite right, so I'll have to deal with that later, I guess. But it's a filter choke. It doesn't really matter. Alright, now that we have this guy made, we can put this in. So it's been a while since I filmed the last footage on this amplifier, because a lot of things have come up since I worked on this and did this. One, I got COVID and I had to get over that, and then the semiconductor shortage is causing problems, and anyways, that's drama for another time, place, and energy. So this is done. It still needs sanded down and, soldered, which I think I can, if I heat this up enough, I can actually burn through it. We'll see. Because I've been lucky with that. So we're going to get this mounted through these holes with this in the middle. And we're going to use a little bit of this silicone to mount it down. Industrial strength adhesive, clear, transparent. What I don't remember is if this is acidic or not. Because what you want to do is you want to make sure this stuff is not acidic. Because otherwise it will corrode and attack the wires. It shouldn't be acidic, but you never know. Cancer alert! No, wait, that's agent. Never mind. Anyway, so that is going to be for this, and then we're going to seal all that up and get this guy mounted. We're going to get that soldered in, and then once we get that soldered in, we got to start taking a look at the power supply section so we can get it rebuilt. So I got the silicone on there, I got the little rubber gasket on there to prevent the coil from shorting to the board, and it's all just, all gooped up in there. The only concern I have is it's a little on the tall side, so we'll have to see how that plays out. Hopefully it doesn't get in the way of anything, but anyways, I have it all siliconed in there, so now really I just got to go let it cure for 24 hours or so, and we can come back to this. Alright, now that it's been 24 hours, the glue is all hardened on this thing, so it can all be soldered in there at this time. So that is what we're going to do, and it's going to be fun. I'm hoping and banking on the idea that I can solder this, because these are insulated, so it's not like I can the solder's not going to stick to it, but if I heat these up enough, it should burn the insulation away, because I did that over here to test it. So I should be able to heat this up really hot and burn the insulation away, and it should allow me to solder. At least that's the theory anyways, and that's what we're going to do. I might need to touch up that a little bit too, because you can see kind of where that got hot over the years. But yeah, I can get that soldered in, and then after we do that, we got to start rebuilding the power supply. Alright, so that little Heiko soldering iron is not going to cut it, so I had to bring out Big Bertha here, and I haven't used this thing in years. I just put another tip on it, a new one, and yeah, it's been a long time, so we're gonna just do that. So let's see how that works. So what I actually did here was I went ahead and took this and I heated the wire itself and slowly added solder and slowly added solder until eventually it burned through the insulation of the wire and it's now soldered in. So that's how we're going to do that for all three of them, and then we're going to trim them down. Well, that was painful, and it was certainly not perfect, but it's the best I can possibly do. Yeah, anyway, so that's all soldered in. These two went really, really well, but notice we used two different color wires because that's how it was originally. So these two went really well, these did not. So I'm thinking this one was the one that would burn off, but this one was highly resistant to heat, and no matter how much heat I got it, it was painful. So I had to pull up on it, use the knife to try to scratch on it, and a little bit of a wire wheel, rub it with the soldering iron over here, and eventually I got it to stick, but it's done. It's whatever. Yeah, next time I do this, I want to do it completely different if there is a next time, because this was just a pain in the ass. Anyways, moving right along. The other thing we need to pay attention to is these RCA jacks, and they're kind of broke free from the board. So we're going to resolder those two because it's a fairly common problem with these. Alright, I have the RCA jack soldered in. I had to do it from the top side because it's just so corroded. I had to work with it a little bit. Got it tacked here. I did it on the bottom side the best I could even with flux, but I got it tacked here, there, and there. So these are solid again. The next thing we have to do is work with these MOSFETs. There's 1, 2, 3, 4, 5, there's 6 of them. There's 12 of them. I already have the parts, and I have to check these resistors. I think I have them on hand. I hope I bought them. And then we're going to go ahead and replace that. Let's get this warmed up. I got all the new parts over here, and this guy. So, and I just got to go through there and see if I have the parts for the resistors. I'm pretty sure I ordered them. I went ahead and grabbed some Q-tips. I got all the transistors removed, and I tried to clean up the area as best as I possibly can. I mean, it's not perfect because you can still see some browning there, and I'm going to try to scratch some of that off with a pick tool or whatever. So, but I did do the best I can to work around this bus bar because this bus bar is not coming out of there. I do not have a bit or a tip big enough to go into my desoldering gun I just got laying over there. But so that's all done. I got the new transistors out. Another thing I'm going to do, just out of precaution, all these resistors tested good, but these MPSA 06 and 56 transistors, they statically check okay. They're probably fine, but out of precaution, I'm going to go ahead and replace them with some new ones. So, as you can tell, I've had those for a while, you know, before the semiconductor shortage was a thing. So we're going to go ahead and replace those 4 along with all of the MOSFETs, and once we do that, we're going to do a power up test and see if it powers up. Now, you can't run this thing long, maybe 30 seconds at most, because these transistors, this is a Class AB amplifier design, these transistors are going to get roasting hot really fast. So it's not advisable to run this thing at full current without a heatsink, but I can turn it on just enough to see if the power supply starts up and it starts drawing current, and if the power supply is idling about where I expect it to be, which is going to be somewhere around 1.2 amps or so. That is half of the current draw of the current, or current draw of the current. Yeah, that makes a lot of sense. That is half of the actual current draw because the 2 power supply rails are in parallel. That's the way I have this thing configured. So that, if I flip this over, that's the current draw from each section. And it's close to being matched, even though it's not 100%. So that's my voltage currently, and that's my current. So that should be running about 0.6 to 0.7 quiescent, which is going to be around 1.4 amps when it idles. At least that's where it should be. but we're gonna see. I got the driver transistors replaced. I have both of them over here, which the polarity of these two are opposite compared to this side. So both sets are replaced. I did that out of precaution because the last thing I want is a leaky junction in one of these on a 50-cent part, wiping out a whole array of increasingly more expensive and hard to get MOSFETs. So I'd rather do that as an insurance policy than that, you know, wiping out, let's see, what is it, 10 MOSFETs? Yeah. 12 MOSFETs. That's, either way, it's expensive. So I'd rather replace $2 worth of parts instead of $20 worth of parts. So what I'm going to do now that I have all the new transistors pulled out and I bent the leads, what I did was I looked at the original ones and approximately figured out where I need to bend these, and did that. But what I want to do is I want to get this board mounted back into the original heatsink, just kind of set it in there, because I need to figure out how tall the transistor sits up off the board. I'm going to tack them in, and the reason why I want to do that is I want to try to limit the amount of component stress on the leads and board and elsewise when I go to clamp the heatsink back on. That way the leads aren't under a lot of stress. They're sitting in their natural position. And that's what I'm going to do next. So I'm going to go grab the heatsink and we're going to do that. Really, that's all there is to it. You just put it in there, push it down, make sure the leads are in there, and that the transistor is actually sitting flat on the board with the leads not stressed at all. And I'm going to tack it down. I'm going to do that with all these. Then after I do that, I want to clean these up a little bit and add some fresh thermal paste on there, and we'll get it all clamped in there the best we can. The actual bottom cover is the heatsink clamp, so I'm going to get the transistors in there at least, and we're going to leave this board in here and we're going to attempt to power up. A first time power up. We got all the transistors in place. They're all tacked down. They appear to be fairly level. They're not really stressed out at all. One of them, I kind of bent the leads a little short, but there's not a whole lot I can do about it. It's not going to be perfect. So now I got to lift it back out, clean the, the crap off the mica insulators and grease them again, and then I'm going to solder the rest of these leads on the back side and trim them up, and then we're ready for a test. I actually changed my mind a little bit now that I'm getting deeper into this. I got all the solder redone on that, but the actual mica insulators, they're starting to flake and fall apart, and the paste is all dry and stuff like that on these ones that have burned up. So the other ones are fine, but those are not. So I think what I'm going to do is I'm going to get rid of those. I'm going to clean up the grease on the heatsink itself, and I'm going to replace those with sill pads, and just add a little bit of thermal compound on each side of the sill pad, and that's probably what I'm going to do. That will help me improve this situation, I think. But in the meantime, before I go that far, I'm going to try to power this amplifier up, and then we're going to see what happens. So let's do that. All right. Okay, let's see here. Grab that. Let me figure out. So that, hold on, power. Okay, so that, yeah, that's the power connection up here. What I do not know is where the remote connection is. So let's take a look at that real quick. Let's see, where's the remote? Speaker. Huh, I gotta find the remote connection. So it must be that middle pin. That's what it looks like. It looks like it's this middle pin. So I'm going to go with that. Power. Okay, positive is on that side. So that's the side away from the LED. So we're going to do positive here. There we go. First energize. Okay, I'm good there. Here we go. Try to get it on the view here. So middle pin. We got a green light, and it's running about 1.4 amps. 1.5, almost 1.6 actually. It's running. We've got a green light. So I can't leave it on much longer than that because these transistors are going to get hot. They're already starting to. Actually, I'm going to leave it on for a little bit longer. Let it run for a bit more. Make sure it's going to idle properly. The current should continue to climb as the bipolar output transistors warm up. That is normal for these amplifiers. Okay, so we'll turn that off. One's getting hot here. Yeah, they're getting warm. Both channels are getting warm, especially the drivers. The drivers are really getting warm. All right, so we got rail voltage. If we didn't have rail voltage, they wouldn't get warm. So we're good there. I think it's safe to continue on. Let's remove that. I think it's safe to continue on with this amplifier. And we're going to go ahead and clean up the heatsink. And we're going to use sill pads instead of that. And then we're going to put it back together. And then we're going to do a sound check. Alrighty then. So now the sill pad is installed in place on both sides. I got a little bit of thermal compound on each side between the transistor and the sill pad. So once the heatsink goes on, it should all be clamped together. So I want to run this up to power a little bit. So the only way to do that is to actually physically put the heatsink back on. So that's what we're going to do. And then we're going to do some testing and see how she performs. So I did a quick power up and an audio check before I put this together, just to make sure that I didn't have to take it all the way back apart again, and it did work. I was only able to test one channel because I do not have the blocks for these. I did not get them, and I do not have them on hand, so I have to use these clip leads, and I only got so many of those. Anyways, one thing that was apparent right away is the audio is cutting in and out real bad, and I had to play with these switches. So what I ended up doing was spraying out the switches with that, and then I sprayed the potentiometers out with that, and then also added a little bit of silicone on the two toroids and put the lid on last night and let it sit. So it's been 24 hours, well, almost 24 hours. It's been long enough to where the silicone should have cured. So I can attempt to wire this back up, and we can do some quick tests to make sure that everything works properly. So let's do that. I'm going to have to share ground because I've got 3 clip leads for my speaker and I need 4. So 2 of these are connected together and it's ground. So I'm going to share the speaker between one lead and then just have the 2 outputs. That's the only way I know I'm going to be able to do that. So one thing I just realized just now is, even though this amplifier looked like it had 2 channels, it is not. This is a parallel amplifier, a single mono block. So these 2 speaker outputs are in parallel. What I did was I took the meter so I could figure out where the ground was, where they're shared, and these 2 are shared and these 2 are shared, which is weird. I'm like, wait a minute, is this not a 2-channel amp? It's not. This is a single channel amplifier. So I only need to hook up to 1 speaker, so we're good there. Alright, I got my phone all queued up over here. Everything's all wired up, so let's turn the power on. It's idling at about where I expected it to be. Do we have power? Where's my power light? Yep, green power, no protection, so set on. There we go. It's not noisy. bass boost works, not noisy. Let's check the switches again. Not noisy. Not noisy. We're good there. Because these were really noisy. Okay, that's good there. Subsonic. Turn that on. I can hear a difference even though you probably can't tell on the camera. Alright, so that works. Alrighty then. Well, I think we're good. So I'm gonna let this run for a bit. But that's going to conclude this amplifier, I think. Let's turn the volume up a little.
Hold me close till I get up. Time is barely on our side.
That's good. That's what I want to do.
The storms we chase are leading us, and love is all we'll ever trust. Yeah. No, I don't want to waste what's left. And on we'll go through the wastelands, through the highways, till my shadow through the sun rays. And on we'll go through the wastelands, through the highways. And on
In case anyone's wondering, I'm just using this as the music. Seems to be working okay. I'm going to test this under power a little bit, but I can only do so much with that power supply because that's a current limited power supply. And I do that on purpose so I don't nuke all of the output transistors and power supply transistors if something happens. But I think that's going to conclude this project. It's been a crazy one, as you can tell here. But yeah, this is all going to go back to the original owner. I hope, maybe, I don't know. It depends on who owns it. But yeah, this is going to go back. But that is a repair, a pretty involved repair of a Precision Power PC1400 PPI American-made amplifier. So if you have a comment, please feel free to leave one, like or dislike the video, hit that subscribe button, and visit the Discord link down below if you want to participate in that. And until next time, thank you for watching.
Back days, I wanna go back days.